we will be discussing positive and negative intervals of a function. All right, so we want to know the intervals when the function is positive and the intervals when the function is negative. If the function sits above the x-axis, it is considered positive. If it sits below the x-axis, it is negative. If it is on the x-axis, it is neither. It is neither positive nor negative because it is 0. All right. So some functions are always positive. So for example, y equals 2x, 2 to the x is an exponential function, and it always sits above the x-axis. Over here, it may look like it's about to touch it, but it's actually just getting very, very, very close. It never actually touches the x-axis or reaches 0. Right? You can never make this function actually equal to 0, but it gets very, very close. But it always sits above the x-axis. So this means it's positive over there and over its entire domain. All right. So this would mean that this function is positive over all real numbers. So I could say from negative infinity to infinity. Or it's just positive. Well, yeah, we'll just say negative infinity to infinity. That's good enough right now. Now, this function over here, this quadratic function, it is a function that is negative over its entire domain because it's sitting below the x-axis. It goes on forever in these directions. It never goes up here into the positive area of our graph. So it is negative over its entire domain from negative infinity to infinity. Now, some functions do have positive and negative regions. They have both. This part of the function is sitting below the x-axis, so it is its negative part. It comes in from negative infinity, from this side, right? And comes up, 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 up until x equals 0. Now, it is not negative at x equals 0 because it is touching 0. So we need an open parentheses. It is actually equal to 0 at 0 in this graph. Positive, it starts at 0 and goes up to infinity. Starts at 0, goes up to infinity. All right? So let's look at example 1. Over which intervals is the function positive? Over which is it negative? So we need both. So positive, we'll start with that. When is this function positive? Well, we're just cutting it right down the middle at the x-axis with positive and negative. Do not confuse this with increasing and decreasing. This is when it's positive. When it's positive, it is sitting above the x-axis. So as you can see, there are two sections in this graph where it is above the x-axis. All right. So this first section is from negative infinity to negative 5. And our second section is from 2 to infinity because it keeps going on forever. Now, the negative part of my graph is the part where it sits below the x-axis. So all of this right here is the negative part of my function. Now, this 0 right at the x-axis does not count, so it is just from negative 5, not including it. That's why I have an I have a parentheses, and going to 2. Now, it should, if I add all these together, cover the entire domain of the function because it has to be positive or negative except for its zeros, except for right there where it's crossing the x-axis. All right, example 2. Identify the intervals over which the function h is positive and negative. So let's look at our positive intervals first. So we're cutting it right down the x-axis. Positive is anything above the x-axis. So we've got right here, and this little section over here, which isn't that little because it goes on forever. All right, this first section is from negative 3 to negative 1.5, it looks like. So we have negative 3 to negative 1.5. Union with this section, which is 1 to 2.5. 1 to 2.5. Union with this last section, which is 5, looks like. Yeah, we're going to call that 5. Union with 5. Looks like it's 5. We'll go with 5. 5 up to infinity. And it's this infinity when I set up to infinity. It's going off to infinity in the x direction. It is going up, but that's not what we're worrying about here. We're worrying about that as x goes over here, it's still positive. Okay. Now our negative intervals. We're negative. We're below the x-axis right here, which is going to be negative infinity to negative 3. union with, well, we have this interval right here. So we've got negative 1.5. Yep, negative 1.5 to 1. And that also includes this section right here, which is 2.5 to 5. All right, that's it. We have our positive and negative intervals. Notice we should, since we have 3 sections right here, have 3 intervals over here. And because we have 3 sections right here, we should have 3 intervals over here. All right. The function x to the 5th minus 7.5x to the 4th minus 3x cubed plus 88x squared minus 30x minus 112.5 has the values listed in the table below. So we have a table of some of its values. Identify to the nearest possible exactness the intervals over which the f of x is positive and when it's negative. Now, we're going to analyze this. As you may have noticed in previous videos if you have watched them, tables are much harder to be exact with when identifying intervals. We're going to do our best though. So we can see right here that our function is negative, correct? And then it goes to 0. So we're going to say that if it is negative all the way up to 0. So we've got negative from negative 5. I'm looking at this right here. Negative 5 up to negative 3. Now, I could, in this case, say that maybe it's negative clear off to negative infinity, and we're going to do that because there's no indication from the table that it goes back up. So we're going to say that if you were to keep going in this direction with the x values, this would continue to be negative. All right. Now, we could keep going with our negatives. Let's see. We become negative again down here. All right. So it's negative here. This one's going to be trickier, right? Because we go from 0. Oh, sorry, not from 0. From negative 1 is our x value. We want to watch our x's. Up to somewhere in 1, maybe 2. It's somewhere in between there. So we can say do 1, like include 1. And it is negative at 1, so we could do that. Or we could say somewhere, this is why we don't like tables very much, between 1 and 2, right? Not very official. It just doesn't look nice. Positive. We've got this section right here. So from negative 3 to negative 1, not including negative 3, negative 1, because it's 0 there. And from 2 to, well, it's 0 right there, so I have to stop. So 2, which it's between 1 and 2, just like our negative. Between 1 and 2 up to 5. And then we can go from 5 on to infinity for this section. A little bit trickier with a table. Tables are a lot harder to be exact with. I don't remember if I have one more example. I do not. Well, under the table.